my talk. So the problem with university rankings. Every year, several platforms, most of which you have heard of listed here, announce rankings of world universities. And they use all kinds of criteria, a very wide range of criteria, very disparate criteria. Some of them highly subjective, like reputation. Some of them are not normalized by size at all, like all those in the yellow here. Which favor larger institutions over smaller ones. And some of them use normalization for size, the ones highlighted in blue. So they do normalize for size, but they don't standardize for size, which is what I will be talking about essentially. So if you look in detail here, you will see a wide range of indicators, some subjective, some not, lack of transparency in almost all of the rankings. They just announce the results, with the only clear exception of Leiden University. And some of them are more detailed than others. All right. So, and that leads to bizarre rankings. For example, if we now concentrate on the size normalized rankings of these universities that I could find, for example, the QS rankings, citations per faculty, you will see some entries even in the top 10 that you would not necessarily expect. The same happens, for example, if you look at the Times Higher Education or Leiden rankings. Shanghai rankings are not even normalized for size, so it's another game altogether. And in this example, I just show the overall ranking of US news, which of course incorporates a lot of factors with a lot of subjectiveness, etc. The bottom line is there are several entries you would not have expected in the top 10. And that is what I will be talking about. Why is this happening? Essentially, these tend to be smaller universities which can score very high citations based on a few outlier papers or members of staff. And that's a direct consequence of the central limit theorem. So these are data picked from the Leiden rankings, and we show here the average citations versus the size of the institutions. So you see that the typical behavior, this triangle-like behavior which is a signature of central limit theorem. So smaller universities can score very high or very low values. And as the size increases, this variation gets smaller until it gets smaller and smaller for very large end. And this is not a phenomenon unique to universities. The same happens in journals every year. And every year you find journals that are highly cited or very low cited being small, and this variation gets smaller as the size increases. And we have discussed this in some previous work, where we introduced this index that I call the phi index or phi index. Essentially, if you think of grabbing at random papers and then forming random journals and then calculating their average, then this inequality holds because the sampling distributions is normally distributed around the mean. The mean is mu in this case. And thanks to the central limit theorem, you can express it in the form depending on the size of the institution. And if you run a numerical experiment, indeed, that's what you find. And this is a typical behavior, so very large fluctuations for smaller size. And this applies to real journals, not just randomly formed journals. For example, 3/4 of all journals are their citation average or impact factor lies within the limits you would expect from the central limit theorem. There is a way to correct for this by rearranging some terms in this inequality. So you can see that this quantity now is bounded by an absolute value. And this is what I will be calling the phi index. It's standardized because of how it is defined, and it's analogous to the z-score in statistics. And if you do the similar random journal experiments for journals, you will see that indeed the phi index is random independent of scale. So let's go back now to universities and ranking. We'll use the same approach. We will use the two indicators from the Leiden rankings, the average number of citations and what they call the mean normalized citation counts. They're normalized by field and publication year. And just to show that there is indeed a problem, here you see Leiden rankings, top 15 ranks, percentage, proportion of papers in the top 5%, top 10%, and mean citation counts. These are all size normalized essentially. And again, you see several entries that you would not have expected. They typically tend to be small universities. Sometimes these are for physics and engineering, physical science and engineering. Some of these universities don't even have a physical science or engineering department. They might have even one member of staff who published a paper. Maybe they were in a university hospital and the paper was picked up by the algorithm so that it's allocated in a physical science category. It's one highly cited paper and it pushed the university high. So some of these cases are the result of a single researcher. And if, of course, it seems more reasonable if you look at the papers in the top percentiles, but then again, this is a non-normalized metric. So of course, this favors smaller institutions. So that's the problem to solve. And if you do this very simple standardization that I showed earlier, you find the following. This is ranking based on the citation average of Leiden, and this is based on the fee index derived from that. So you will see there are two regimes. Left of this vertical line, these universities are higher than the global average. So therefore, if they're higher in size, then they are doing better. They're pushed to lower ranks, better ranks of the fee index. And these are the universities that you would have expected here. Stanford, Nanyang, Georgia Tech, National University of Singapore, MIT, etc. And the smaller universities here that were very high, in very good ranks of the average citations, you will see that they get bumped to worse rankings here. For example, Charles Sturt, Stellenbosch, etc. And this happens also if you incorporate a fractional counting, where every paper is allocated to fractionally to the number of universities of its authors. Again, very similar behavior. And the same if you look at the mean normalized citation counts. What does that mean? This is looking at physics and physical sciences and engineering, which is one umbrella field, but it consists of thousands of smaller subfields. And this is where they have introduced, the Leiden group have introduced normalization for each subfield. So again, very similar behavior. And if you look at the top rankings, you get intuitively reasonable outcomes. For example, this is the Leiden ranking for all subjects for the mean normalized citation counts. This is the fee index. And this is likewise physics and engineering. This is fee index physics and engineering. And likewise for fractional countings. So to conclude, university rankings suffer from a range of problems, mostly subjectiveness of criteria, absence of normalization, and lack of data transparency. But even when these are not there, I argue that size standardization is needed. I applied a similar technique as I've applied before for impact factors, and I find that the rankings then shift considerably, such that the fee rankings reduce the impact of outliers that skew the rankings in favor of the smaller universities, and they incorporate, on the other end, size normalization without favoring the larger institutions. So therefore, I claim that citations require normalization and standardization for fairer rankings. Thank you very much. And if anyone is interested, we have an APS-sponsored panel discussion on Wednesday. Thank you.